How'd you like to listen to .NET Rocks with no ads? Easy. Become a patron. For just $5 a month, you get access to a private RSS feed where all the shows have no ads. $20 a month will get you that and a special .NET Rocks patron mug. Sign up now at patreon.netrocks.com. Hey, Carl and Richard here with your 2024 NDC schedule.
We'll be at as many NDC conferences as possible this year, and you should consider attending no matter what. The Copenhagen Developers Festival happens August 26th through the 30th. Tickets at cphdevfest.com.
NDC Porto is happening October 14th through the 18th. The early bird discount ends June 14th. Tickets at ndcporto.com.
And we'll see you there, we hope.
Hey, guess what? It's .NET Rocks. I'm Carl Franklin.
And I'm Richard Campbell.
And we're here again.
Yes, we keep doing this.
Keep doing this
soon
thing.
People are going to talk.
Yeah, hopefully. That's the whole point.
There you go.
We talk about everything, not just .NET, but we're a podcast for .NET developers. That's the way we've always been.
And .NET developers do a lot of stuff these days, it seems. I think they always have.
Yeah. I have a little bit of a story and a product to talk about for Better Know Framework. So roll the music.
All right, man, what do you got?
Well, I gave myself a birthday present this year.
Oh, happy birthday.
Thank you. Happy birthday to you too, sir.
Yeah, right. It's about the same time, isn't it?
Yeah. I replaced the stock in-dash stereo system in my 2012 Honda CR-V.
Mm-hmm.
Had it a long time.
Yeah. 2012's a while.
Yeah, but it's a great car. But I replaced it with something new that has Apple CarPlay and all that stuff.
Ah, right.
And I did a lot of research, and I found the best bang for the buck was about $549. I got it at Best Buy. It's a Pioneer AVH 2550 NEX.
All right. So what is it?
So it does everything, right? But mostly it connects to your phone, and it will either use Android Auto, which is the Android version,
right,
or Apple CarPlay. Both are registered trademarks or whatever.
Yeah.
It also does Bluetooth, but here's the thing. Unlike most in-car dashes that have their own GPS, right? This one, it connects to it has radio and all that stuff that you would imagine. But Apple CarPlay, in my case,
because you're an iPhone user,
does everything. Yeah, because I'm an iPhone user. My brother has another one that does Android Auto, but they both do the same thing. Basically, you use your phone. So I use Waze to navigate, and it shows right on the console.
And it's better in every way.
It's better in every way than the standard stuff that comes in a car, certainly, and even better than Google Maps, I think.
Yeah. Well, it is Google Maps, actually, under the hood.
Yeah.
Owned by Google.
But you get the sort of reports of, traffic hazards and police and stuff.
Which apparently the police watch closely and then just remove themselves whenever somebody identifies a speed trap. They go, nope, that speed trap's gone.
Well, let me tell you, I drove to Pennsylvania over the weekend and back, 6-hour trip, and it worked like a dream.
Yeah. Kept you out of the bad traffic.
Yeah. And except for the bad traffic, which, it told me about. It was too late, but it could have rerouted me.
But often to tell you and say it's still the best route.
Yes, it's still the best route. Exactly. Yeah. And most of it was just caused by bad weather.
So really this Pioneer device is a big screen, relatively speaking, in your car that ties to your phone so that you don't have to look at your phone to do nav.
Right. So you can listen to anything on your phone that you have access to, right?
Spotify et al.
Yep. And before I was connecting audio with Bluetooth. Right. And there's a delay with Bluetooth, but this one has a USB jack, a female jack that comes right out of the dashboard.
Nice.
And you plug your phone right into it. So there's no delay whenever you pause something or you want to.
And you're charging. So,
charging, skipping forward, skipping ahead.
Well, because the other reality is you're running the GPS sensors the whole time because it's actually doing the nav work. So it's going to mow your battery unless it's plugged in. Yep.
And it's plugged in. I had no problem with that.
Good.
And also my car came with a little voice button on the steering wheel.
Yeah.
But it really didn't do anything.
No. It's the old voice. Old voice.
But this connects directly to it. So I can essentially, anytime I want, I can say, call this person, text message this person.
And it's now sending that to the phone.
Sending it to the phone, right? I can send text messages or whatever. I can skip ahead if I don't like the ads in my podcast. Hey, should I have said that?
You shouldn't say that. No. Have you noticed what your business is? Like, come on.
Yeah. But, I've heard these same ads a million times and I skip through. I just had a great experience. Now, I will tell you a gotcha, and I'm sorry, guys, I'm taking up too much time with this, but there was a gotcha. When I first set out, I was using an existing lightning cable, and I was getting audio dropouts.
And it was the cable?
It was the cable. I stopped at a mall. I went to the Apple store. I got an official Apple iOS
You spent
lightning,
$60 on a cable.
and it worked. It fixed it.
If you actually watch YouTube on disassembling some of those $60 cables, there's a lot of stuff in those cables. They're not just wires.
Right. So it didn't work with a third-party cable, but it did with the iOS cable.
Okay.
All right. Who's talking to us, Richard?
Grabbed a comment off of show 1899 back in May of 2024 when we talked to our friend Aaron Erickson, who hadn't been on the show in a very long time, the nomadic developer, who we now call the nomadic AI developer, because why not, right?
And it
was part of a sort of 2-show set, because we also did that show with Sean Wildermuth talking about being in a computing career later in your life, which solicited a huge response.
Oh, yeah. That was great.
And Sean, I think, expressed a lot of worries that all of us had. And then in comes Aaron, who's like, hey, I've totally retooled my career again in my late 50s. And I'm now working for nVidia, all in on the new technology, which I thought it was just an interesting bounce to do. And this is a comment from Trev, who says, hey, I love the conversation today. Aaron has had an amazing career, and I would suggest that nVidia are super lucky to have him on board. The conversation on generative AI touched on the travel industry, and I thought that I would share something from a presentation I attended last week. A New Zealand travel agency who, during the pandemic, lost something like 80% of its value and 60% of its staff has a terrible problem now. They can't hire travel agents because during the pandemic, they all retrained in other careers and they're not coming back. So they've now turned to large language models and new automation to solve this problem. And he's obviously, Trev uses the service because he said, normally, if you want an itinerary for a trip, it would take the travel agent a couple of hours to put it together. Now I get it in 2 minutes. And it's based on all my wants and wishes, all the little details and so forth. And that includes confirming the hotels, setting up all the flights, optimizing to my flight needs, your time, your budget, what stopovers. Is a perfect illustration of where these technologies can transform the industry. And thanks so much for the show.
Awesome.
Yeah, we're dealing with it's a double whammy, isn't it? The pandemic definitely tore up a bunch of industry.
Yeah. And
then we have this new technology that gives us a better interface. I mean, you've always been able to build your own travel itinerary. It's just, I still do it this way where I got TripIt open over here and I've got various websites for airlines there and different hotels. And, the fact that you could pull that all together with software using a modern travel agency and it costs the agency less to deliver you faster service, like that's what automation is all about.
I know a whole bunch of office space that is currently available.
Well, a lot of people are not, still working from home, and it's not going to change.
Yeah.
So, or at least it seems not to. So, Trev, thank you so much for your comment, and a copy of Music to Code By is on its way to you. And if you'd like a copy of Music to Code By, write a comment on the website at .netrocks.com or on the Facebooks. We publish every show there. And if you comment there and I read it on the show, we'll send you a copy of Music to Code By.
Yeah, Music to Code By still going strong after all these years. A great way to stay focused when you're writing code.
I got a nice note from a listener who I had sent the code to so that they could get a copy of it. He was like, this changes the way I work.
Yeah, it is good.
Yeah.
Okay, let us introduce our guests today who have never been on the show before. So I'm really looking forward to talking to them. Malte Ørstavik is a passionate machine learning engineer working for Norkart, operating in the geospatial domain. And Mathilde Ørstavik has a master's degree in geographical IT with a specialization in geographical AI. You can read their full bios at .netrocks.com, of course, but that'll get us started anyway. Welcome, guys.
Thank you.
Thank you.
All right. So that first voice you heard was Mathilde. The second one was Malte. Just to identify for our listeners, so who wants to start with the elevator pitch? What are you guys doing out there?
Do you want me to take the first one, Mathilde?
Yeah,
I can do that.
Yes, thank you. Well, Norkart, is a Norwegian IT company at this point, I guess. Historically, we did a lot of maps and stuff like that, but we have more and more pivoted into doing IT, and we deliver a lot of different products within the geospatial domain. We have exactly 3.14 or pi products per developer at our place.
So great.
So you have to, if you add new products, you have to hire more developers to keep the ratio correct. Is that the plan?
Yes, exactly.
Okay. Yeah. Every developer that gets hired has to bring in 3.14 products.
So great.
Oh my goodness. So, you're using primarily aerial data. I guess there's some satellites, some aircraft. Of course, drones have changed this landscape as well. But then turning it into usable imagery. It's one thing to have a bunch of photos, another thing to turn it into something that's really usable. That's got to be pretty software intensive.
Yeah, definitely. We're mostly using different aerial images and creating like servers that can handle both 3D tiles as well as the aerial images and vector data that we can then implement into different softwares. So we're mostly using the different maps more than creating them.
Okay. So yeah, somebody else is involved in collecting the data. Now you're trying to get value from it.
Exactly.
Oh yeah. Well, that's how long has that been a problem in our industry? We collect lots of data. We just don't do anything with it. So how does machine learning come into the equation?
So the first thing we started to test was how we could improve the vector data based on what is actually visible in the aerial images. So traditionally, what you do is that you look at the aerial images manually, and then you draw the maps from those images, which is a manual process, very time consuming, and of course is prone to errors because it's easy to not detect everything.
Mm-hmm.
So we started testing.
You're using the human to do the pattern recognition to say that's an image of this area. Here's how it lays together.
Yeah, this is a building. This is its walls.
Right.
This is the details of the buildings and so on, and roads and everything.
Wow.
So we started testing if we could use machine learning to detect the buildings for us, and also different types of objects.
That must be a lot of work. Job security for a lot of people.
Yeah, definitely. So we started testing this back in, I think it was 2016, which is when image recognition got really good. Mm-hmm. And it worked pretty well. And then we've continued developing these methods until now, more or less.
Okay.
When you were describing what you used, just this image data, and that you go and get it, don't these databases exist? We were talking about Google Maps, and that certainly is a rich database of topical imagery. Is it something that you can't use for copyright reasons, or you need to do your own imaging in order to get the level of detail? Like, why is it that you couldn't use something off the shelf?
Yeah, level of detail is definitely a big part of it. And ownership and cost also. So in Norway, all the municipalities have aerial images of high resolution for their areas that they update maybe every year for the big municipalities, maybe every fourth year for the smaller ones. Mm-hmm. But it's very high resolution, and the level of detail in the Norwegian maps is incredibly high. They're very detailed, and they're on a Norwegian-specific format. Mm-hmm. So the level of detail in Norwegian maps are way higher than Google Maps. Yes.
So that's what you're using. You're using the Norwegian data that maps that already exist. So you're not actually going out and flying drones over buildings and taking pictures yourself or whatever.
Yeah, exactly. So originally back in 1961 and so on, Norkart did produce aerial images.
Right.
And then they became a software company.
I see.
Like everybody else.
Yeah.
Yes.
But I guess your goal is not to do navigation, I imagine. You're doing other things with the data.
Yeah. Mostly other things. We also do some navigation, but mostly other things, yes.
So what do people want this data for? Like, what are they asking for?
Oh, so many things. It can be visually. to see other types of data together with the aerial images. But when you're talking about the vector data, the vector maps, it's for analysis.
Planning of infrastructure, taxation in Norway, at least, you get taxed based on what buildings you have on your property.
Right.
So it's really important to know. Or if a fire starts, it's really important for the firefighters to know what buildings exists where,
Sure.
All that kind of stuff. So
yeah, and it needs to be regularly updated. So you've got your municipalities, the big ones at least, scanning every year. Like that also introduces an interesting angle of how is the land evolving year over year. Certainly for British Columbia, which I often equate, similar to Norway in some respects, except we're really big. It's tree coverage, right? Between logging, forest fires, and regrowth, you have to go and image those areas to really understand what's the state of the land.
Yeah, exactly.
Yeah, for sure. And we've seen others also that has done exactly that in Norway as well. Tried to map out what trees are where. Yeah.
Yeah.
Where does development come in? Are you doing mostly Python programming against this data, or are you using any cloud computing? What are you using?
Yeah, we're mostly using Python, like everybody else is in machine learning, at least for this project. And this is mostly trained on our own data center. So we have 2 L40 GPUs with 64 gigabytes of space each. And these are quite actually big enough to, you get some really good results trying to identifying objects from the aerial images. Yeah.
Oh, wow. Okay. But so not even using the cloud, you're running your own. You guys really are old school AI.
Yeah.
Yeah, we're running our own, but we've also tried the cloud and experimented a bit with that. But we figured out that for this project, we have other projects as well, of course. But for this project, we're using our own data center. Yeah.
And so an L40, and I'll include a link for the show notes if folks want to take a look at these things. I mean, it looks like a little computer, essentially. Something that looks like it should be in a data center. Like, is it anything more than just like an RTX 4090 in a chassis?
I don't remember the exact specs of the 4090. Does it have 64 gigabytes of?
I don't think so, but
I think that's the biggest part of it, at least that we have. That
it's just a sheer amount of memory.
Yeah. So you can have more images in memory at the same time.
And that's got to be what it's all about, really. It's just like, how much RAM do you have available to you to be able to do those image analysis?
Yeah, for sure.
I'm just looking it up. Yeah, 24 gigs on a 4090 and 48 on an L40. But pipeline wise, like they're not that different, but they're still different. And yeah, PCIe interface. So, and 300 watts, so it'll keep a room warm.
Oh yeah, you need some cooling for that.
Oh yeah, no kidding. But
absolutely.
So you use a pair of these?
Yeah, we have 2.
That's nice.
We have 2, but there are 64 gigabytes of RAM and not 48. Those I'm not sure.
Yeah. So maybe a newer model.
Maybe, I'm not sure. Yeah.
That's cool. I got to find how much these things cost. I need not that I need rack gear anymore. I'm doing everything I can not to buy any more rack related equipment. Like, please stop. Like, don't do it. Yeah, $5,000 a crack, man. $5,000.
Yeah, 5,000. Yeah. Well, don't you remember how much we paid, Mathilde? I don't remember.
Oh.
I don't remember.
No, I don't.
It would have been in kroner anyway, so nobody would know.
All I know is that it was cheaper than doing it in the cloud.
Oh, wow. Okay.
Yeah,
because of course
we're doing a lot of testing.
Right, because the cloud's only dinging you by the minute. So at some point you have to do the projection and go, hey, if we just buy this, we're good for a certain amount of time. I mean, the upside to using the cloud is they're going to upgrade their hardware for you. Now, you guys are on the hook for X many years, probably 4 or 5 years of amortization over this stuff to make it make sense. But I get it. Totally makes sense. It's reasonable.
I'm interested in what other, applications that we have. And one that came to mind is law enforcement. Does law enforcement use your data in any way? that you can talk about?
Good question. I don't think so, but I'm not completely sure because we have a lot of customers that use our data that we don't necessarily know about.
Right. So how do you train a model to figure out that that's a building and that's a wall?
Yeah, so the really great thing about this is that since we already have the vector maps, people have already done the manual work looking at these images.
Right, so you're working from known images.
Yeah, we can just use the existing data that we have and we can produce enormous amount of training data automatically. So that's the really great thing about these models. So what we do is that we combine aerial images from a small area around 512 times 512 pixels, and we get the existing data for that same area, and we can combine those images to produce the input image and the label image. And then we can basically produce as much data as we want because we have data for all of Norway and we also have historical data. So we can combine this and then train our data or train our models with that automatically produced data.
Okay. And so, I mean, I think two things come with that. One is you're just saving time on a new set of data. Say, yes, that's the same building from last time. If it doesn't identify it, maybe that's because the building has changed in some way.
Exactly.
I wonder how sensitive it would be. Like if a building puts solar panels on its roof, so now it looks a little different. Is it still able to map it, or does it pull it up as I don't know what this is?
Yeah, it depends on what is in the training data. So if there were some new kind of solar panels popping up in Norway, our model would most likely not detect it.
Right.
But if it's solar panels similar to ones we already have, we would most likely detect it.
So is your vector data mapped down to that level? It says that's not only a building, but that's a building with solar panels on the roof?
If the solar panels are in the training data, we can train a model with that. Yeah. So we have tested that as well, but then we need to specifically have the training data with solar panels.
Right.
And when you're drawing these things by hand, you're doing these sort of annotations, I guess you would say. Really, are you just like drawing lines and saying this is how long this, I don't know, how wide and how high, widths and heights, three-dimensional data, I guess you would say? Or how detailed do those hand drawings get?
Well, we're not actually doing the drawing since this has already been done by people specialized in this field in different companies. Oh,
okay. I was under the impression when you first spoke about it that you had a team of people that were manually drawing on top of images. But
different companies in Norway do this.
So you're just pure data.
Yeah. And it's done now. So you've trained the model.
Yeah.
And that's what we're trying to automate by this manual drawing process.
Right.
Yeah.
So each time new images come in, you're able to then use the machine learning model to establish that this is the same image of the same area with these same buildings.
Exactly.
How often does the data change?
It depends on the municipality how often they buy new images. But it can be up to every year. So when there are new images, we can run our model, detect all the buildings in the municipality, and we then compare those results to the existing buildings, which means that we can figure out where there have been changes. Have someone, is there new buildings popping up, or has any of the buildings changed? And that data set is very interesting for the municipalities because then they can figure out where their maps are not as similar to the reality visible in the images.
What about things like seasonality? Like how good is this going to map a picture from the summer versus a picture in the winter?
Yeah, good question. So the companies that take the aerial images, they usually always take the images in the same time of the year.
Right. So just avoid the problem by we only photograph this area in July should be pretty consistent. And of course, you need clear days because taking pictures in the rain, questionable value.
Yeah. So they have to wait for good weather.
Yeah. And in Norway, there's only a kind of good weather, in the spring and summer. So that's when all of these pictures are taken.
Been there. Yeah. I've been there in June. I've been there in November, and there's a difference.
Yeah.
Okay. So, I mean, we definitely picked an area here of using the machine learning models to do the image recognition. So you reduce the cost of introducing new images to the system, and then help the customer. In this case, you typically municipalities identify new buildings. That's a great class of work. Are there other classes of work here? Like I would think things like, are trees dying off or, our cultural changes, those kinds of impacts might be turned up this way too.
Yeah, absolutely.
Yeah, but the main one you said was, detecting buildings. And actually, one of the municipalities in Norway, they actually detected a lot of new buildings so that their property tax could be lowered for everyone in that municipality.
Right.
And they could still get the same income.
Because they recognized there was more buildings out there that they didn't know about that were responsible for tax.
Exactly.
Yeah. So some had to pay more, but in general, everyone could pay less.
Right.
Yeah.
The cost were already being burdened, but not everybody was paying their fair share effectively.
Right.
Yeah, exactly.
Like from a municipal data perspective, this is really powerful because otherwise you do this with surveyors, which you think mapping out aerial imagery is costly. Send a group of people out to go measure everything by hand. Like that takes a lot of time.
Yeah.
Exactly. And also some of the buildings we can see that hasn't been updated in the vector data in a long time, but the machine learning model can actually detect those. So in some ways, they're also doing a better job, the models. Yeah.
Right.
So it's interesting to see.
Because they've got a better vantage point for all of this. So primarily a Python problem. It's just munging the data and doing the mapping together.
Yeah, it's all Python, this project. And what we do is that we use our GPUs, of course. And then during training, we will, what can you call it, like live sample all of the images from databases, and thereby, really take care of a lot of pictures at the same time. However, when you do this thing live, you also have to make sure that you get the data that you want. For instance, in Norway, it's Norway is 98.3% of forest. So if you just pick random tiles from Norway, you're just going to have
trees.
Yeah, you're just going to get trees and mountain and
more trees.
Exactly.
Yeah.
So we have to be smart how to pick out this data when we're doing it live and stuff. So we have some rules that has to be set for some of the images that has to contain buildings and stuff.
Right.
Yeah.
And then
so this is the main thing that we've been working on. What is the optimal way to select data to get the best models?
Right. To really shave down you don't have to, you're not getting maps of the whole country. You're just getting maps of the interesting areas, the places where people are.
Yeah.
So, and
training data for the interesting parts.
Right.
Because if all the model sees are images of forests, it's just going to learn that nothing is building and it's going to be correct most of the time.
Yes. Yeah.
But it's not going to be useful.
Yeah. How many buildings in Norway? None.
Yeah.
98.3% correct right there.
Yeah, there. Yeah, it's pretty darn accurate, actually.
Yeah.
3.14 buildings in Norway.
Yeah. 3.14. Yeah.
All right. Well, we should break for a moment for these very important messages.
It's common for a business application to contain 15% repetitive code just because of metaprogramming limitations in the C# language. Why write boilerplate manually when a machine could generate it for you? Enter MetaLlama, the code generation and verification toolkit for C#. Their C# to C# template language is simply amazing. Logging, caching, memento, observable. If it's repetitive, MetaLlama can automate it. Visit metallama.net today and learn to automate your code patterns with their free edition. Remember, it's MetaLlama with one L. METALAMA.net. Hey, Carl here. If you're wondering how to step up your debugging game, Raygun's crash reporting now supports portable PDB and offline error storage, perfect for apps built with .NET MAUI or Windows Universal Platform. Just upload your PDBs, and Raygun will enrich your stack traces with crucial details. Never miss a beat in your development cycle again. Let Raygun take the hassle out of error tracking. Visit raygun.com/.netrocks. That's Raygun, RAYGUN.com/DOTNETROCKS for your free 14-day trial.
And we're back. It's .NET Rocks. I'm Richard Campbell. That's Carl Franklin.
Yo.
We're talking to Mathilde and Malte about the challenge of geospatial data as well as how machine learning is helping out there. Because you know, most of the time when I'm dealing with machine learning models, we're trying to get as much diverse data as possible for the training set. And you've just painted a really great case of where you don't want to do that because there's a lot of data that's irrelevant here. Like you really have to cut it down to just the populated areas, which is mostly coastal for Norway, if I remember my geography in Norway. But even that wouldn't necessarily be a good criteria. You just have to, you said it just before the break there, Mathilde, does it have a building in it?
Yeah.
Right. That's probably, and I'm sure there's like wilderness huts out there somewhere that's like mostly forest, but there's a hut.
Yeah. We did test in the beginning, just have a rule that said we only want training data if there is at least 5% building within that tile.
Right.
Which works really well if you want to focus on detecting buildings.
Yeah.
But what happened is that whenever the model saw areas that wasn't connected to a building, nature that is not typically surrounding buildings, it falsely detected buildings, like white spots of snow.
Right.
Was detected as a building.
Oops.
Like the face on Mars, right? There's rock formations that could be building-ish. Like
yeah.
Well, they could be igloos, right?
That's an Inuit thing, but okay.
Yeah, well, you know, it's cold. There's snow. There's ice.
Yeah.
Somebody could make an igloo. I don't think it would have a street address, though. No mailbox.
I would also think that you've got lots of highways and things where there's not a lot around it for some stretch. Like I've driven on those where it was just forest on both sides. I don't know that you need to map all the highways, but you know, that would be something I'd want to discriminate for. You're not going to get buildings from that.
Or at least land and water, you know, unused land or unoccupied land and water, bodies of water.
Yeah. Interesting set of problems. So then, but the whole point here is to keep adding new data because they do want to look at things over time. Do you end up building like kind of time lapses to be able to look at a particular location and say, here is several years and how it's evolving?
So what we've actually done is that we've created a system that creates training data while we're training the model. And what it does is that it just selects randomly within a set of rules.
Right.
So we have some rules that is creating data for tiles with buildings.
How big is a tile?
512 times 512 pixels.
Okay. And space that scale wise could be anything then.
Yeah, it's so the images have a resolution of 10 centimeters, between 10 and 30 centimeters per pixel.
Right.
In spatial resolution. Yeah.
And then you're looking at a 512 by 512 tile. I mean, that's just a big old jigsaw puzzle. Holy man. Like you do have geospatial data associated with that shot, right? You know roughly where it was taken.
Yes, exactly. So we have the coordinates for the lower left corner. We have the spatial resolution, which means that we can calculate where in the real world we are. So when we can detect a building within that image, we can figure out where that building is.
Now, wouldn't that geospatial tagging be the best thing for defining a set for a given training set for a given area? Because you already know roughly where it is?
Yes, it is exactly. And what we have done to speed the process of picking the best data for us is that we have within 5 meters of every building in Norway, we have made these boundary boxes. Right. And then we made an SQLite database that we have mapped all of these data points into, so that we know exactly where all the buildings in Norway are, and we can just pick from those areas. Yeah, so it goes really fast.
Oh, that's great.
So you've derived a data set essentially based on this image that says, okay, these are the buildings we know about.
Yeah.
And then you can
and talk about map reduce. That's exactly what that is.
Exactly.
It creates a set of boundary boxes. Now, I think the challenge with using the geospatial filter is if they've built out of the known range, you're going to miss it. Like you kind of want to take a perimeter around that or look larger to say, where's a new set of buildings that we've just never mapped before? That's got to be kind of the hardest problem.
Yeah, so when we're looking for new buildings and actually analyzing the aerial images, we analyze every image.
Okay.
So the selection within the building areas is only for creating the training data. Yeah.
Oh, I see. Now, do you actually get images of all of Norway? I got to think the municipalities only map the area they're responsible for.
No, we have images for all of Norway because the municipalities are responsible for their areas, but then there's also the Norwegian Mapping Authority. They also have images for all of Norway with the lower resolution, but still very good quality.
Right. So I presume you have provinces or states, something like that, sub-regions within the country that have an authority that's responsible for that.
Yes, we have what's called fylker, which would be a state, I guess.
What'd you call me?
Yeah.
But I guess this is part of the problem is the municipality is going to give you very high resolution data, relatively speaking, where the state level data will be low resolution because it's mostly trees. So it doesn't need to be that precise.
Yeah,
exactly.
Although we had a situation in British Columbia with the pine beetle where they were doing mapping showing that pine trees were being killed in the forests, like in the wilderness. The other trees weren't affected, but they wanted, because it increased the forest fire risk. So they're looking for where are there concentrations of pine trees that were dying because they burn really, really well and create worse fires. And so they were doing all of this mapping and occasionally you got to see some of it where it's just like this whole slope is just pine trees and they're all red now, where all the other kinds of trees around it are still green. Like a very interesting visualization data. Like I'm such a geek on this stuff. Like, let's get into multispectral data where we could actually look at the stress levels of plants and, those different effects, or even CO2 emission and IR maps of all of this data to show what are the buildings that are environmentally inefficient or that have high emissions. Like there's a ton you can do with this data if you're scanning enough frequency.
Yeah, definitely. So we've also tested using the infrared images because we also have infrared images for a lot of areas in Norway. And the infrared images will give us different information than the regular RGB images. And we've also included height data. So this is one of the exciting things here. We have all of this different data and we can combine it into our models in different ways to detect different types of objects. And different data will be good for different types of objects.
How do you get the height data?
It's also collected for Norway by I think it's also the Mapping Authority.
The vector stuff. Yeah.
So they must have something that they're pinging how far they are on the ground at any given point. Like, are they actually giving you the heights of different buildings? That to me would be astonishing.
Yeah, it's height for different, the point cloud.
Okay.
It is very accurate. Yeah. It's very cool to look at.
Is the height data specific to a tile or is there different height data within the tile?
Different within the tile. It's also very high resolution.
So per building, basically.
Well, it'll be higher than that.
Higher.
Yeah, it's many points for one building.
Yeah.
Yeah, sure.
No, if you have a height data per 10 centimeter pixel, you're going to be able to map out a rooftop. You might be able to distinguish individual, like an air conditioner sitting on a roof would have a different height from the rest of the roof. Yeah.
Yeah, or a chimney or something else. Yeah. Yeah,
definitely. If you look at the height data, you can definitely see what kind of areas you're looking at.
Crazy.
It's very accurate. Yeah. That's and it helps us to differentiate, for example, terrace from an actual building.
Right. I was just thinking it's easier buildings have a different height profile than normal terrain does. So it might be a good way to say that's probably a building because it's too uniform or it has a, consistent slope, like things that only humans would do. So it's actually not a bad building detector, even if the visual image doesn't necessarily show it up. The height data could really trigger you on saying that looks like a structure.
Yeah.
So are there other things besides like patches of snow that have confounded the algorithm or whatever, the detection algorithm?
We also found Atlantis.
Oh,
where there's it says that there's buildings out in the water. Yeah.
You found Atlantis.
Yes. Yeah, because it's in the training data in the beginning, there wasn't really enough data with water, so it thought that patches in the water was also buildings. So that's where Atlantis is. That's in Norway, if everyone was wondering. Yeah,
that's why we haven't been able to find it. Aristotle was busy talking about the Mediterranean. He had no idea. It was the North Sea the whole time.
Wow.
Exactly. Yeah.
Yeah. The height data is not going to help you there. The ocean's a pretty consistent height, but you could easily have shapes in the water that could be mistaken for buildings.
Yeah.
I mean, we're almost anthropomorphizing the software's ability to recognize images, right? Like it's making mistakes where this is just not a good enough training set.
Yeah.
Although, yeah, I don't know how you even filter for that. Do you give it a set of things in the water that are not buildings to help it to avoid that?
Yeah, exactly.
Can you do that negative option, or you only train it towards what it should find as a building?
No, we have to also include because when we started out, we only did buildings, and in the area with high concentration of buildings, it worked really well. But then when we did it in a more rural area, it didn't work so well. So then we also now have to include some water and forests and snow and all that kind of stuff. Yeah.
And so you're training it to actually say that is objects in the water, so not buildings.
Yes, exactly. Yeah, we're saying...
Yeah, it's only binary. So we say building or not building. Right. And we make sure that there are images of water in the data set that is labeled as not building.
As not building. Okay.
Yeah. But one thing that we've done to make sure, like, you can kind of imagine that you need some water, you need some forest, you need some mountain, you need some building, and this will be a representation of reality. But it's really difficult to know how much of the different types of data that the model needs. So what we've done is that we start out with a set of rules for how much the data the model should have for each category. Mm-hmm. But then we also let the model find the data itself. So while we're training the model, we're testing different images to see how well the model is performing. Mm-hmm. And if the model performs badly, we add that data to the training data set.
Right. Okay. So then I understand why you have L40s, because you're going to retrain a lot. You have several different sets of building, not building, and you're going to put different weights on them and retrain and see. I mean, I got to imagine then you run it through a functional data set and see how much is wrong. And are there collections that are wrong that you could then tell you we should be harder on identifying water structures as not building. Yeah. At some point, it's going to start ignoring real buildings.
Yeah.
It's a nice feedback loop.
Exactly. And that actually happened with the snow example, because one of the reasons that snow can look similar to a building is that we have greenhouses. And greenhouses can have a lot of reflection, which means that it looks white, right, similar to snow. So when we added more pictures of snow, we suddenly had greenhouses that were not correctly detected as a building. Yeah, so this is always a difficult part.
It's a great problem.
What is the sauna to domicile ratio?
We wish we had a number for that one. We wish we had a number for that one.
One of the reasons I brought up the solar panel thing is I did the Future of Energy talk in Norway, and I could not find good data on residential solar because there's enough of it that it's just not well mapped. Right. And mostly,
we should look into that.
Well, and it's interesting that Norway didn't have commercial solar being land used for solar panels, because anywhere you have flat land, you have better uses for it than solar panels. But tops of buildings are covered in solar panels. It's because it's a good use for that. But again, the government did not have good data on just how much, pseudo commercial rooftop solar there was. So. I'd like you to answer that question for me. Not that I need to answer it anymore, but it was one of those things where it's like, it's a great question to ask. And in theory, you could build a training set around, can we detect solar panels from this data? Absolutely. And then, if somebody's willing to pay for the compute time to figure that out and maybe get a map of the reality of what's out there.
Yeah. And one of our colleagues is actually working on a system that can figure out which areas are good for having solar panels in Norway, based on all our geographical data.
Yeah.
So if we combine that with where there are existing solar panels, you can find really good areas.
Yeah, lots of possibilities there for utilizing that. It makes sense for you to go to a building that's there that you know about. It doesn't have solar on the roof, and go. You would get good results from putting solar panels up here. We've got a data set that shows that.
Yeah.
Yeah, it's not always an obvious thing, but it speaks to the power of this data, just making it easier to manage, because it's a lot of information.
Yeah.
I'd like the decomposition model. You can take all these different sources of data and break it into tiles and then map it into a common system.
Do you foresee having to upgrade your in-house systems dramatically? Are you growing that much? And do you have a plan to grow as your requirements grow?
I mean, we're definitely growing, but I'd say that this is maybe like one project that we're working on. It's continuously training, continuously getting better. Mm-hmm. But we're also in the meantime doing a lot of other projects. So yeah, it's mostly those that are in line of growing. So we won't buy any more GPUs.
Okay.
Anytime soon, I think.
I guess the question is like, how long are you waiting to finish a training set these days? Like, when is it long enough that buying another one would make sense?
How long is the training now?
How long does a training run take right now?
Yeah, it takes
on that parallel L40s.
Yeah, when training a new model on new data from scratch, it would take between 2 and 3 weeks for it to be good.
Wow.
Yeah.
That's a long time.
Yeah.
Right.
Like, so if you had 4 L40s, would it be a week?
Yeah, in theory, yeah.
Or is it just the fact that you can wait? Is it just the fact that you can wait for it and nobody's knocking on the door saying, hey, you know?
Yeah, we can. It's okay for us to wait 3-4 weeks for this, because we have a model that is good, and then we're testing different things, and we're not sitting, waiting, and doing nothing. We have different projects, so this is running in the background.
But it sounds like those 2 L40s are probably running at their limit most of the time.
Yeah.
Like they're just,
they're
saturated.
They are.
Yeah.
So are your other projects also dealing with geospatial data in these models, or you said this is just one project? Are there any other projects that you're doing that are totally different?
Yeah, definitely.
We have a bunch of projects. Yeah. So the biggest one we're doing right now is probably trying to make sense of Norwegian zonal plans. And these zonal plans, I don't know how it is over in the States, but in Norway, you have zonal plans, and that's all the municipalities have their own zonal plans, and they say something about how the land in that municipality should be used. So it can say
right. So there's zone for residential, zone for commercial, zone for industrial.
Yeah,
and that's all you're allowed to use. I mean, that's a common practice, right? You generally don't want a chemical plant beside the residential area. Those kinds of things.
Yeah, and they're very detailed, and could be anything like, here you cannot build a building that's higher than 5 meters, and over here you can't build a road; it's illegal. All these kind of things. Right. So what we're doing is that just like everyone else, they're using the large language models to try to make sense of these plans. Yeah.
Okay.
And is that using the geospatial data?
Yeah.
Yeah.
Yes. Yeah, Mathilde, you can go.
So everything sort of that you do revolves around this data.
Yeah, usually.
Maybe it sounds like.
Yeah. So the zonal plans have 2 parts. You have the document, which can be up to hundreds of pages with really difficult text to understand, and then you have a part that it's the map that tells us what part of Norway it's the zonal plan is covering.
Got it.
And that map usually has a lot of information that is not in the text document. So we combine information from the map and the text document together in an LLM to try to make to understand the content and to figure out which part of the document is specific for a property.
That's good.
So you're using a large language model in that, so that people can use like a text expression to fetch the data?
Yeah, exactly. So, as much as I don't know personally, when I see a chatbot, I don't really like it that much, at least on commercial sites. Yeah. But so now I'm sitting here making a chatbot.
Because on one hand, I'm like, I like that you guys are the old school AI. You were doing it before it was cool. But no, you've been infected by the LLM monster too, right? It's just sort of consumed all of us the past 2 years.
I especially hate happy chatbots, overly enthusiastically happy chatbots.
We'll make ours a little bit meaner. Yeah,
a little grumpier, sarcastic.
Actually, you will probably get better usage if you throw in snarky comments every once in a while, and even little insults.
Yeah.
Is there a Don Rickles mode?
We'll make one now for sure.
Yeah. When somebody says that data is wrong, you could say your face is wrong.
Yeah. Yeah, for sure. We'll look into that. I think it's important to
make it a little more exciting to use anyway.
Yeah, right.
So what's next? What's in your inbox, you guys? Mathilde, what's next for you?
Project-wise?
Mm-hmm.
Or anything.
Well, we've been testing a lot of different ideas with our data and our products. And one thing we do is that we invite the different product teams to have hackathons with us.
Right.
And we try to figure out how AI can fit into their products.
Mm-hmm.
And one of the hackathons that was really fun was one we did together with our monorepo team. So we have a platform for running our front-end applications. So we have all of our 3.14 products per developer in one big monorepo.
Right.
Cool.
And we try to figure out how AI can help developers when they're coding in that big monorepo.
All right.
And
good.
we figured out that you're now actually allowed to create a Visual Studio Code extension on top of the GitHub Copilot extension that allows you to build your own functionality into the GitHub Copilot chat.
Wow.
And
Wow.
we've had a lot of fun with that.
That sounds fun.
Yeah,
sounds
so
like a
we've
great
added
project.
Yeah, so we've added our own functionality into that, where you can chat with specific Norkart documentation. You can add a support chat to our chat room directly after chatting. If you don't get your answer, you can summarize your chat and directly have it posted to our chat room. Stuff like that.
Cool. How about you, Malte? What's in your inbox?
Oof. Well, it's going to be making some new personalities for the chatbot. That's probably the first thing I'm going to do.
Don Rickles mode.
Your face.
No, but it is trying to figure out if this actually is going to work, these zonal plans and finishing, that product and trying to show it to our users and see if they're happy with it, because it's really difficult to like prompt these correctly and try to make I assume most people these days are familiar with RAG architecture. I don't know, but trying to optimize the searching part and the prompting part and stuff like that. So there's a lot of tricksing and stuff with that these days for sure. And then we're also, looking into, as I mentioned, chatbots. It's not, that fun. It's not the best thing in the world. So we're trying to look at how we can parse these zonal plans in other ways, such as, making summarizing pages and trying to just extract useful information from these documents, depending on what property you're on. Yeah.
Very good. Well, I wish you good luck. Richard and I wish you good luck in the future. And, if there's anything we're talking about, come on back at a later time and we'll do another show.
Yeah, customizing GitHub Copilot sounds like a cool topic.
Sounds like a great topic.
Yeah, for sure.
Yeah. All right. Thanks again.
All right. Thank you, guys.
Thanks for having us.
Yeah, thanks for having us.
You bet. And we'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Plop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got transmitter banned by the FCC.